In this quick lesson, we're just going to look at how to find expected values in a contingency table for the chi-square test of independence. So let's look at this problem, learning at home. Student all studied various aspects of grade school children and their mothers and reported their findings in the article, Learning to Read at Home in School. The researchers gave a questionnaire to parents of 66 children in kindergarten through second grade. 2 social class groups, middle and working, were identified based on the mother's occupation. So here we have nursery rhyme knowledge was split into categories of few, so students who knew a few nursery rhymes, some nursery rhymes, and lots of nursery rhymes. I'm assuming all these were defined as to what made up a few, some, and lots. And then we have social class, middle, and working. So when we look at this, this is a basic contingency table, but what it doesn't have are the marginal values. In order to do any type, determine the expected value, because remember, here you have all the observed values for each category. How many middle class knew a few, knew some, knew lots? How many working class knew a few, knew some, knew lots? They're the observed numbers, the 4, the 13, the 15, 5, 11, 18. We need to find the expected. To do that, you need to finish the contingency table and find those marginal values. So what we have to do first, now some of the contingency tables you're going to come across, the marginal values are found for you. This one, it's not. So how many total middle class families were surveyed? You add up the 4, the 13, and the 15, and we get 32. How many working class? That's your 5 plus 11 plus 18 gives you 34. Now, of the total 66 children, how many declared they only knew a few nursery rhymes? So that would be 9. How many declared they knew some? That would be 24. And how many declared they knew lots? That would be 33. Now, just to double check that you did your math right, add each row and each column of marginal values separately to make sure you get the same number. So looking down, we have 32 plus 34, which is 66. And then going across, I have 33 and 24 gives me 57 plus 9 is 66. So here's our table now with the marginal values added. So let's think about this for a minute. In order to do a chi-square test for independence, we need observed values and expected values. What we're testing for in a chi-square test for independence is something called association. Is there an association between social class and how much knowledge kids have of nursery rhymes? This could lead to do different social classes do more reading at home type of thing. We always start, our null of course is there is no association between the two, and the alternative is there is an association between the two. But to come up with the chi-square test statistic, we have to find those expected values. These are the values that would be observed if no association existed. The values that would be observed if no association, and we can find those expected values using these marginal totals and the total for our sample. So let's think about it this way. If 9 kids out of 66 knew a few nursery rhymes, that means, let's see, 9 over 66 equals 0.136. So that means about 13.6% of the total knew a few nursery rhymes. Well, that 13.6%, if there is no association between nursery rhyme knowledge and social class, would be the same across both social classes, meaning 13.6% of the middle class and 13.6% of the working class. So it would be 0.136 times how many total middle class kids were there? 32. And that 0.136 would give us an expected value of 4.35. And then the same percent, 13.6% of the 34 working class students, we would expect 4.62. So that would mean for the middle class, we would expect approximately 4.35 students. We observed 4 that knew a few nursery rhymes. For the working class, we would expect 4.62, but we observed 5. Neither numbers are too far off, so as we start to look at this particular sample, the numbers are appearing very close. The observed numbers are appearing very close to what is expected. Now, I want you to take a moment and let's look at the formula sheet to see how that tells us how to find expected values for a test for independence. Let's go up to our formula sheet. And your test for independence is over here. Notice the chi-square formula is going to be exactly the same as it was for the goodness of fit test. But what changes, there are a couple things. Number one, look down here on this side. The first thing is how we find the expected value. This formula tells us to take the row, this represents the row total, times the column total, divide by the number in the sample. So let's go back and see if that's what we actually did. So we took 9 over 66, multiplied it by 32 to get our expected value, 0.35. The 9 represented the column total. The 32 represented, if you look up here, the row total, and the 66 is what you divide at the end. So if you take 9 times 32 and divide by 66, you will get about 4.36. There was more rounding here to get us the 4.35, but we were very close. So my recommendation is when you are finding these expected values, what you're going to do for each box in your contingency table. So to find a few for middle class, you do 32 times 9 divided by 66 was the formula again R times C over little n for your sample size. So for example, let's look at this box here. This represents the expected value that a working class family child knew a lot of nursery rhymes. You would take, if we follow the formula, the row totals 34, the column totals 33, and you would divide by 66. So take 34 times 33 divided by 66, and you get an expected value of 17. Again, not too far off from the observed value of 18. So this is how you're going to go through and get all your expected values when doing the test for independence.